Okay, moving on to the second part of chapter 2, we're going to talk about the metric system, or what they call the system international system. The metric system is the way to measure, and in science, we only use the metric system. Now, I know in the United States, we use the English system, which is weird because we're the only ones that use the English system. Even the English don't use the English system. But when you're taking measurements in science, we use the metric system because there's way more people that use the metric system than the English system. So if you make a great discovery and you have all your information in inches and things like that, most people don't understand it. So we go with what people understand the most. So again, anytime in lab situation or whatever, you're always going to use the metric system. We do not use the English system in science. The nice thing about the metric system, it's based on units of 10. So it's really easy to convert. The English system is terrible. You go from, there's 12 inches in a foot, there's 3 feet in a yard, there's 5,280 feet in a mile. It's not a uniform system. The metric system is. Everything's in units of tens. And the quantities, the big things that we use, when we measure length, we use a meter. A meter is a little bit more than a yard. I think it's like 39, a couple of inches past. Mass is a kilogram, but if we're using a small amount, we'd use a gram. Temperature is in Kelvin, which is based on the Celsius scale, so we pretty much use the Celsius scale. Time is second, that's a universal. Amount of substance, we're going to talk about later, a mole. It's a measuring unit in chemistry. And then electric current is an ampere, which we don't really use a lot in chemistry, but we'll talk about a little bit. Okay, so here's the common prefixes. And again, this is why it's so easy to use the metric system, because everything's based on units of 10. So if I want to switch from kilograms to grams, I just have to move the decimal over 3 because it's 1,000 to the base unit. So the metric system is really easy to convert because, again, you have everything based on units of 10. Okay, a meter is a standard unit of length. If we were going to measure small units, like when we would use an inch, we use centimeters. They have defined it. I'm not going to worry about if you know that a meter is the distance light travels in a vacuum in that short of a second. But a meter is the standard unit of length. It is about, like I said, it's about 39 inches, a little bit more than a yard. Okay, and here's some common ones. Meter, centimeter, millimeter, and kilometer or kilometer are the most used units. Okay, a kilometer is where we would use a mile, but it's smaller than that. So if you ever go up to Canada, and if you get to go 88 kilometers per hour if you're going 55, I'll give you an idea. So that's the common length units we use. Most of the time when we measure in chemistry, we use centimeters. There's even smaller ones, millimeters, and there's picometers and nanometers and all that. But for us in the lab, those would be the ones we'd use the most. Okay, and to give you an idea, 1 inch is 2.54 centimeters. So if you wanted to convert, those units, that would be a common conversion. Or, is it? I'm trying to think, 5 centimeters or 4 inches in a 10 centimeters or something like that. But again, it's a conversion. But again, we're just going to use centimeters. We're not going to have to worry about converting it. Okay, so when you are trying to solve problems like conversions, we use what they call dimension analysis. It converts one unit to another unit. And all you use is conversion factors. A conversion factor is like multiplying by 1. Like there is 60 seconds in a minute. They equal each other, but if I want to switch something from seconds to minutes, I got to use that conversion. So I'm going to show you how to use these, and we use these all the time in chemistry. Okay, here's an example. 1 kilometer is 1,000 meters. So if I want to change either kilometers to meters or meters to kilometers, I'm going to use, if I'm going from meters to kilometers, I'm going to set it up this way. Well, how do I know that? If I write meters first, meters have to be opposite of each other because you want them to cancel each other out. Okay, so meters here, the meters cancel out, and then you got kilometers. If I'm trying to change kilometers into meters, now I'm going to put kilometer on the bottom and meters on top. So these conversion, this is like multiplying by 1, and this is. The way you set it up is, what are you starting with? What are you trying to find? What are you trying to get rid of? Okay, so any unit can be converted to another unit by using conversion factors. And again, remember, a conversion factor is like multiplying by 1. Okay, if I have 2 meters and I want to change it to kilometers, again, I know 1 kilometer is 1,000 meters. And I know meters is going on the bottom because I started with meters here. So whatever I start with, that's what I want to put on the bottom. So they cancel each other out. I don't want meters squared. I want the meters to disappear. And then I put 1 kilometer, so then I just divide and I get 0.002. So there's 0.002 kilometers in 2 meters. Okay. Okay, so units are treated like numbers and they cancel. And again, that's what I was talking about. I want to get rid of the meters. So I want to make sure meters is on the bottom. They cancel each other out. I do not want to multiply them because I don't want meters squared. I want to know how many kilometers there are in 2 meters. So that's how I do it that way. Okay. And again, the original unit has to go, and your conversion has to be on the bottom, has to go in the denominator. The numerator, the number on top, wants to be your new unit, what you're looking for. Okay, so you can use this, you can use dimension analysis to solve all kinds of problems in chemistry and anything. But again, dimension analysis is basically converting from one form to another. Okay, they have maps that they solve, and you'll see them in here. I don't know that I tend to use them that much. It's a little bit more writing than I like to do, but it's up to you guys whether you want to do it or not, and I'll show you some examples. Okay, if I want to convert 250 centimeters to meters, well, I know that there's 100 meters, there's 100 centimeters, excuse me, in 1 meter. So I'm going to have to use that quantity. And again, here's the maps. I don't know that you necessarily have to write all them down. What I would write down is what I know, 215 centimeters times 1 meter is 100 centimeters. That's just like multiplying by 1. So now you can see I got rid of centimeters and I got meters, and that's what I'm looking for. So I'm just going to take 215 and I'm going to divide by 100. Centimeters cancel out, and so now I know that there's 2.15 meters and 215 centimeters. I converted it from one unit to the other. They still equal each other, but now it's in a unit I probably want to work with, okay? If I want to do 125 meters to kilometers, again, I'm going to write down 125 meters. I want meters on the bottom and kilometers on top. I know there's 1 kilometer in 1,000 meters. So here's where I'm going to write it down. My meters are going to cancel out. I'm going to have kilometers left over. Then I just divide and I get my answer. Okay, so whenever you're using dimension analysis, it's a way to solve a problem, and really what you're doing is you're converting from one unit to another. Now, it's not always just one step. Sometimes it's more. A lot of them you can do in one step. Sometimes you have to do in 2. Sometimes you have to do in 3. It depends on what you're converting. But again, it's just the same thing. You're multiplying by a conversion factor that really equals 1. Okay, how many micrometers? Again, here, 1 meter on the bottom, and there's 1,000,000 micrometers in 1 meter. I don't know that I'll have you do units that small, but you get the idea. And then you just multiply. Okay. Whenever you're using dimension analysis, remember there's a series of conversions, and I just talked about that. It's not always just one. Sometimes you have to do 2, 3, 4. It just depends on what you're converting. Okay. If I want to do days into seconds, does anybody know how many seconds there are in a day? Well, offhand, no, but I can figure it out. Okay, so 1 day. What do I know about 1 day? I know 1 day is 24 hours. So days on the bottom, because they're going to cancel out, hours on top. Then I know 1 hour is 60 minutes. I also know that there's 60 seconds in a minute. Now I'm at the unit that I want. I'm at seconds. That's good. So I'm going to go 24 times 60 times 60. You don't have to divide by 1 and divide by 1 and divide by 1. I guess if you want to, you can, but you're going to get the same answer. So that's when you're going to get. Now days cancel out, hours cancel out, minutes cancel out. I got seconds left over, and you can't see it, and I'm really sorry, but it's 8.64 times 10 to the 4th, or if you wanted to write it out the other way, it would be 86,400. So now you know how many seconds there are in a day. And again, this took several conversions, but these are all common knowledge things. So you can use that. We'll look at the time here. How are we doing? Oh, we've got plenty of time. Okay, how many feet in 250 centimeters? Well, centimeters to inches to feet. So again, it's going to take more than 1. So I take what I know, 250 centimeters, 1 inch on top, 2.54 centimeters on the bottom. That's a common conversion. Okay. Now I got rid of centimeters, I got inches. Now I can change inches to feet because I know there's 12 inches in a foot. And again, inches are going to cancel out and feet are left over. And my question says how many feet, so I know I'm in the right unit now. So I'm going to take 250. I'm going to divide by 2.54, and then I'm going to divide by 12, and I get 8.2 feet. That's how many feet there are in 250 centimeters. Okay, so again, sometimes you need more than one conversion. Okay, and again, here's another one with how many meters are there in 5 yards. You'd have to do your conversions. You'd have to change yards to feet. I know there's 3 feet in a yard. I'd have to change feet to inches. I know there's 12 inches in a foot. And then I know that in centimeters, it's 2.54 centimeters, and then change it to meters. So 5 yards, 3 feet in a yard. Now I got rid of yards, I got feet. Then I know that 1 foot is 12 inches. So now I got rid of feet and I got inches. Then I got to change inches to centimeters, 2.54. Put that on the top. And then the last thing I got to do is I got to change centimeters to meters. So I'm going to put 100 centimeters on the bottom and 1 meter on top. And that'd be my last conversion. And I don't think if you can see your answer. Sorry, I'm in the way. I try to find a spot to go, but I always seem to get in the way. But the answer is 4.57 meters. And again, sorry about that. But again, it's more than one conversion, but each one of these is multiplying by 1. Okay. Here we're doing centimeters cubed because again, we're doing centimeters times centimeters times centimeters. You're just going to multiply those 3 numbers together. Okay. We got inches by inches by inches, I think. And that's how many inches cubed there are. And all I did was multiply the 3 numbers together. And then I want to change that. Well, I know that there's 2.54 centimeters in 1 inch. Get rid of inches, and then you got your answer. So I can convert from metric to English, which we don't do a lot, you guys, because we just use metric. But you know how to do it if you have to. Okay? Another, when we're working with measurements, one of the most common measurements we use in chemistry is called mass. And mass is how much matter an object has. It's really easy to measure. You just put it on a scale. Okay? So, and when we measure mass in the lab, we do grams. We use the electronic scales and they tell us grams. If you're talking about people, you would do kilograms. Okay. Another thing we talk about is weight. Now, most people think mass and weight are the same. On Earth, they are, because weight takes in the effect of gravity. So on Earth, the factor that you'd multiply by is 1, so it's not a big deal. But your weight would be different if you're on the moon. There's a lot less gravity on the moon, so your weight is a lot less, but your mass is still the same. Okay, so your mass doesn't change, but your weight changes, okay? Because weight calculates gravity into the picture. Okay, so again, mass is independent of location. It doesn't matter where you are, your mass is the same, but your weight can be different. Like in space, you're weightless because there's no gravity. At least that's what they say. I don't know. I've never been to space, so I can't tell you guys for sure. So mass is a standard measurement in the metric system. In small units, we use grams. Bigger units, we use kilograms. Okay, and they have conversions again. If you want to convert your mass from from kilograms to pounds, 2.2 is the conversion. I don't know that you have to use 2.2015, but 2.2 is what I've always used for a conversion. Okay, so again, in chemistry, we use grams and kilograms. If you were like a pharmacist or something, you'd probably use milligrams, like in medicines and stuff, or micrograms. But really, the big ones to use are grams and kilograms. Okay, so if I wanted to convert 343 grams to kilograms, it's very simple. I take what I know, 343 grams. Now I'm going to put grams on the bottom, right here. Grams, they cancel out. I know 1 kilogram is 1,000 grams, so all I have to do is divide. And I get 3.43 kilograms in 1 gram, or in 343 grams. Okay, again, easy conversion, just like multiplying by 1. Okay, so we got one more here. I'll just do the chart because we're just about out of time. So 0.12 kilograms. Again, now I'm going to put kilograms on the bottom, grams on top. And in this case, I'm going to multiply. And then I'm going to change it to centigrams. 1 gram is 1,000 or 100 centigrams. And there you go. 1.2 times 10 to the 4th. Okay. So that's where we're going to end today. There'll be, after this lecture, there'll be some practice problems on conversions it'll follow right along in the module. If you got questions, you guys, let me know and I'll talk to you soon.